Thank you for inviting me. I'm delighted to have the opportunity to speak at the National Science Foundation. First, what is this talk about? This talk is about what I teach. It's based on research into usability of science and societal problems. It's based on listening to my students. What they say has changed significantly in the last 15 years, so has what I say. My goals are to work to accelerate the incorporation of climate change knowledge into design, planning, engineering, and management. I like to teach techniques of problem solving. How do we, our students, gain some control over how climate change will impact the planet and our lives? I want to start with this figure. It is from an in-class survey on the day that the 2022 IPCC mitigation report was released. For this group of students, almost two-thirds of the responses are that it will take 30 years or longer to reduce our emissions by 50%. The poll's results are positioned next to the fact that many countries have made commitments to reduce their emissions by 50% by 2030, including the United States and the European Union. These commitments were first made in 2015, and since 2015, global emissions of carbon dioxide have continued to increase. Who are my students? My target students are from any department who wants strategies on how to incorporate climate knowledge into their professions, their lives. I originally targeted professional masters, for example, public health, urban planning, business, and public policy. I've had students from many disciplines, and they all have interest in climate change by the time they make it to my class. I've learned much from my students, and they changed what and how I teach. My first lesson was almost immediate. The students who were not climate scientists were far more attuned to the importance and the consequences of a warming planet. They were less stovepiped in their points of view. They were much less concerned about scientific uncertainty than natural scientists. They did not see scientific uncertainty as a primary barrier to addressing climate change. In 2008, I decided it was disingenuous to continue to teach about the 2 degrees Celsius limit in avoiding dangerous climate change. I felt it was more realistic to imagine a world 4 degrees warmer, and that thinking about that 4-degree world might provide concrete motivation to keep it from becoming a reality by more aggressive mitigation of our emissions. Then, in 2014, I noticed that people thought if we cut emissions quickly, then we would avoid sea level rise, avoid increasing flooding and drought, and avoid more heat waves. The message that they heard was if we cut emissions, that we would return to the climate of our past. This was simply not true. I kept changing my message because all the evidence was of a warming planet, that the warming was accelerating, and it would continue for decades. That evidence included that we were in fact increasing, not reducing our emissions. Further, if we considered what actually needed to be done to reduce our emissions, then we had no clear path on how to do it. Statements that it was just a matter of political will were naive. As I gave talks, sometimes Earth Day talks, I noticed something else. There was a culture of blame, who to blame, and who to hold accountable. Much of this blame was towards the fossil fuel industry. There was also much attention on the government, especially the federal government, to fix the problem of climate change. I noticed a generational divide, that the older people in the crowds were much more interested in blaming corporations and governments and actions. These experiences strongly influenced both my teaching and public writing. At this point, we can say with near certainty that for the coming decades, sea level will rise. It will ultimately be measured in meters. Ice will be melting. This has broad consequences. The average temperature of Earth's surface will continue to increase. The weather will change, amplifying both the extremes of water excess and water scarcity. This will all continue until we intervene effectively in reducing the greenhouse gas forcing that is leading to the accumulation of heat in our planet. After that intervention, we will have taken a step towards limiting the increase in temperature, but we will not be rushing back to a pre-industrial climate. It does not take a deep analysis to come to a set of conclusions about climate change. First, we need to reduce our emissions of greenhouse gases in order to limit the warming, maintain our ability to cope, and reduce the remediation we will have to perform. There is urgency as there are environmental thresholds that can be viewed as tipping points that we need to avoid. We must develop technology and practice to remove carbon dioxide from the atmosphere. Second, we will need to adapt to a warming planet, and that adaptation is not simple. The more we allow the planet to warm, the more difficult it becomes. Adaptation can be reactive, we respond to disruption and crisis, or adaptation can be anticipatory, we plan and take steps to prepare for disruption. Third, there is a deficiency of research and planning to support adaptation and geoengineering, that is, climate interventions. I repeat, we must learn to remove carbon dioxide from the atmosphere. The challenges of a warming planet are daunting, but they cannot be overwhelming. Responding to global warming needs to span all of society. It will be part of what we do to live on this planet. It is worth thinking about how we have behaved with regard to reducing emissions. We have known for decades that the easiest way for us to reduce carbon dioxide emissions is through more efficient use of the fossil fuels we burn. In 2004, Stephen Pacala and Robert Socolow introduced the concept of stabilization wedges to flatten the curve of carbon dioxide emissions. A primary point in their paper was that we could flatten the emissions curve with existing technology, then reduce emissions. We became very familiar with flattening the curve during the COVID-19 pandemic. Though we might be familiar with the concept, we did not prove to be uniformly enthusiastic about doing it. In their vision, as the curve was being flattened, new technology was being developed. The new technology would then accelerate the reduction. In many cases, increased efficiency in the use of existing technology would have rapid payback on costs. In fact, they would save money. This would seem to line up with economic sensibilities. Yet, we have not pursued these ideas at a scale that has led to a reduction of emissions. In fact, we cannot convincingly argue that we have even reduced the rate of increase of carbon dioxide emissions. If we consider the carbon dioxide curve here from Mauna Loa in parts per million starting in the late 1950s, the increase appears relentless. We see the annual cycle due largely to the respiration of the Northern Hemisphere biosphere, the growth and decay of plants. Over this time span, there have proved to be only two ways that we achieve temporary global reduction in emissions: economic recession and the dissolution and deindustrialization of the Soviet Union. It is important to say that this curve does not say that we have done nothing. We have, in fact, following some of the vision of Pacala and Socolow, indeed, through efforts in efficiency, conversion of coal to natural gas, increased nuclear power, and the emergence of wind and solar energy, we have increased energy production and avoided emissions. We have many other successes as well. We need to make them durable. However, the increasing global demand for energy by an ever-increasing fraction of a growing population has been filled primarily by fossil fuels. The portion of our energy produced by fossil fuels has remained globally stubbornly around 70%. What does it say that we have cost-effective means to reduce our emissions, but we have not reduced the emissions in any absolute sense? It says that such behavior is simply not in our nature. There's not collective agreement on the need to reduce emissions, and it is a very complex and difficult undertaking. This situation is frustrating, depressing, angering, and can leave one with despair. What I tried to teach is how to take some control over the challenges of climate change. This requires recognizing that we have substantial knowledge base of living with our climate and weather. We need to use that knowledge to overcome the anxieties that lead to paralysis and inaction. We need to understand systems and methods of problem solving to overcome the barriers to applying climate knowledge to planning, design, engineering, and management. To make good livings and lives requires knowledge. It requires understanding how we get things done and change institution. It requires understanding how to recognize opportunities for action and to take advantage of those opportunities. It requires knowing how to accelerate the emergence of those opportunities. Humans are an adapting species, and we have adapted to weather and climate throughout our history. We adapted to the end of the last ice age as the temperature lurched upwards and ice melted. There were great floods and rising sea level. We have adapted to extreme cold in Siberia. Others are thriving in the hot, arid Middle East. The ancient and amazing underground tunnels that bring water to form the Turpan oasis in northwest China provide historical testimony to humans' abilities to adapt. Humans have always experienced changing climates and harsh weather. It is part of our very nature. In the temperate, mostly stable climate of the past 10,000 years, we have grown accustomed to large and small adaptations. We noticed and reacted to the medieval warm period and the Little Ice Age. We have internalized expected climate extremes in our behavior and practice. We have seen industry and policy changes when we've experienced new extremes. For example, stronger building codes on the South Florida coast following Hurricane Andrew. These two facts, that we can live in extreme conditions and that we have innate experience in managing our exposure to climate, establish, for me, some confidence in our capacity to cope with the coming changes. Pointing out the ability to adapt could be said to be facile. I do not want to suggest no worries. We can cope with ease. We have an immense number of people, unsustainable demand on resources, and unmanaged waste. The speed and magnitude of the upcoming climate change is unprecedented. However, we have great advantage over our ancestors. We know what is coming. We know what is causing the warming. In fact, we know technologically how to manage the warming. This knowledge of the future is an astounding advantage. For those who decide to use that knowledge, it provides great opportunity. What do I mean when I say I teach problem solving? Scientists and engineers are trained to solve certain types of problems. They produce knowledge as well as structures and devices that do things. Some of their work takes on larger roles in society, business, and the economy. The work that takes on these larger roles, perhaps, fits naturally into things that people want. We want energy and all of the advantages that it brings. We do not especially want to deal with the waste of energy products, be it coal ash, acid rain, or carbon dioxide. We like to imagine that we can place our waste into our environment without substantial consequence. When our scientific research tells us we cannot keep accumulating our waste without consequence, that does not fit naturally into what we want. In fact, it is counter to what we want. We do not want to clean up our messes. However, our well-being demands that we clean up our messes. When science produces this less alluring type of knowledge, we are faced with problems whose solutions demand that we better understand problem solving. We have this knowledge, but we need to know what to do with it, and we need to know how to do it. We need to change institutions. We need to change economic power structures. We challenge the tenuous balance of power between nations. Ultimately, in the case of climate change, we challenge human behavior, and human behavior is not easily changed. Problem solving includes understanding the system we're trying to change. Where are the barriers? What are the motivations for those barriers? How do you overcome those barriers? These are barriers that we need to anticipate, negotiate, manage, and pass. We need to move past lamenting that we are thwarted. We need to quit stating that making progress is only a matter of political will, because there is someone else's political will on the other side of many of those barriers. These are competing interests. The important point, changing such a system takes time. The approach to problem solving that I teach has evolved over time. It is deeply informed by my experiences at NASA to address the phrase in our performance plans to solve complex problems with no known solutions. It is likewise informed by the unique aspects of my career that found me being asked to manage change in entrenched organizations. There are some fundamental elements to my approach. These are knowledge system theory, science usability theory, framing, communications and continuity, engagement, uncertainty management, skills for complex problem solving that are multi-constituency, multi-jurisdictional, intersectional problems, decision analysis, and decision making. Each one of these subjects could take multiple presentations or chapters. I want to focus on the skills of space and time. When faced with a complex problem, one strategy to gain some insight and understanding is to analyze the roles of space and time. One of the fundamental and challenging aspects of climate change is complexity of time. We are increasing our greenhouse gas emissions at an exponential rate. It takes time to realize the temperature effects of those emissions. If we were to successfully intervene, the benefits of that intervention are realized in the future. The temperature is rising. That increase is accelerating. And the effects of that temperature rise take time to be realized throughout the environment. If there is one thing COVID has taught us, as a collective, we do not deal well with challenges that have complex time evolution. For those who take on solving such a complex problem, understanding time is crucial. What is long-term and short-term? This axis shows time from now out to 100 years. Based on experience, I pose that timescales are best defined by human dimensions. On what timescales do we plan? When we build a power plant or a bridge, how long do we expect it to last? 50 years is a good span to separate long from short. Climate change has often been characterized as a long-term problem. However, there are many short-term issues that affect climate change. National security, energy security, and health security all influence our ability to address climate change. The economy is always of critical immediate importance. We want a good economy. Elections have large impacts on the willingness to address climate change. But is climate really a long-term problem? We've gotten to the point that each 30-year average of weather, climate is statistically different than the previous 30 years. Each 10-year average of weather, climate is statistically different than the previous 10 years. Each 10 years of accumulation of carbon dioxide adds heat whose effects will be realized for centuries. Development of plans, design, policy, and permitting, acquisition of funding, all of these essential parts of getting things done take years, often decades. There is, in fact, a short-term urgency of climate change. Aspects of climate change problem solving are present at all time scale. Evidence, our behavior, generally supports that these short-term crises impede our ability to address climate change. National security, energy security, and health security and threats to the economy usually motivate us to spring back to what we know how to do. And what we know how to do is burn fossil fuels. There are always crises, short-term imperatives. We need to expect them. We need to break the pattern of springing back to fossil fuels. We need to manage and sustain focus on climate change through these crises. What about space, spatial scales? We have challenges that are individual, local, regional, national, international, and global. We know that actions and events at one scale influence other scales. As we increase the spatial scales, we introduce more people, more jurisdictions, more agencies, more power holders, and more stakeholders. As we increase spatial scales, we incorporate more and more wealth holders. We also introduce more and more people without wealth. We incorporate more issues of inequity, social justice, and ethical values. A skill that I champion is to consider a problem in terms of time, space, and wealth. Long-term global problems intuitively are the most difficult to solve. Short-term local problems are intuitively easier. Wealth and ethical considerations increase the complexity in unpredictable ways because they rely on human choices, human values, and free will. Mitigation is global and long-term. The degree of difficulty is highest. The scale of adaptation can be local and near-term. Indeed, it can be individual and autonomous. Cost-benefit is clear and outcomes are measurable. There is benefit to identify local and near-term problems. They are more tractable. They play to measurable outcomes and successes. They are morale-boosting. Successes provide models that will scale up. They can have long-term and global impact. Now I want to think about one of our major messages. Headlines scream that we have until 2030 to reduce our emissions or we face catastrophe. As I was writing this talk, I saw the headline that we are firmly on track toward an unlivable world. We see one report, one headline after another, that we have an increasingly narrow path to meet the goal of limiting warming to 1.5 degrees. That path requires reductions of emissions to near zero by 2050. Along that path, we look to milestones that by 2020 we would see some reduction. We would be approaching 50% by 2030. Let's return to the results of the poll of my students. Some countries have made voluntary commitments to reduce their emissions by 50% by 2030. But 2/3 of my climate-smart students, who I imagine to be leaders in addressing climate change, do not see that reduction to 2030 goals happening in even 30 years. There's serious discord between the public discourse and what my students discern as truth. Let's consider this urgent message to reduce emissions by 2030 to avoid catastrophe. In this graph, the horizontal axis is time. It is split. On the left, time is measured in years. On the right, time is measured in decades. The vertical axis represents emissions. The line shows our history of increasing emissions. This curve represents an intervention that takes us off of our historical path towards a goal such as 1.5 or 2 degree rise in average surface air temperature. The next curve shows that if we wait just a small number of years, then we have to turn off the emissions faster. Likewise, the third curve. We eventually get to a point of the fashionable thought experiment of having to turn off our emissions immediately to be able to meet the temperature targets. We are already very close to that point. I am a senior citizen, and I expect to see the 1.5 degree threshold in my lifetime. If we pose we have until 2030 or all is lost, then we take the hardest global problem, mitigation, and place it on the shortest time scale, which is effectively a singularity. Problem solving breaks down. The ability of people to gain agency over the problems of climate change appears impossible. We will not reduce emissions by 50% by 2030. In 2031, will not only be habitable, but it will have some pretty nice weather. This will cause us climate scientists grief. I need to pull these ideas together. Earlier, I imagined how would I coach those who wanted to gain some control over the problem. I said I would advocate using knowledge to overcome anxiety that leads to paralysis and inaction. Use knowledge to recognize and overcome barriers to applying climate knowledge. Identify and implement no regrets mitigation and adaptation actions. In the talk so far, I have introduced some ideas with the intention to argue that if we think about how those in our population interested in getting things done actually do get things done, then this seemingly impossible problem of climate change becomes more tractable. These ideas include framing. We have knowledge and experience living with our climate. Proof of concept. Emissions can be reduced and economic growth maintained. Understanding the societal problem-solving system to know where there will always be barriers and develop skills to overcome them to help us find opportunities, make opportunities, and we need to persist in incorporating climate knowledge in all spatial and temporal scales. We need to spread out time so that people can see how they can fit in. Evaluating local activities that have real impact and can serve as models for emergent solutions is central to making progress. Climate change is a problem of accumulation. We accumulate carbon dioxide and we accumulate heat. The accumulation of carbon dioxide comes from an accumulation of choices we have made over many decades. Most of these choices seemed justifiable and many seemed right at the time. It is a classic tragedy of the commons. I pose that we need to consider the solution to climate change as an accumulation of choices. There is no single answer, no one switch to flip. If you think about it, that which can be gained by blaming corporations and looking to government for fixes is limited. It leads to more waiting. Climate change is so pervasive that virtually every profession, every field of endeavor needs champions. These champions pursue solutions, and those solutions scale up through influence and successes. There is a major difference to the uncountable number of small and large choices that have led to our carbon dioxide pollution and the uncountable number of small and large choices that will lead to solutions. The solutions will have to be organizing rather than fragmenting. They will be fighting human entropy. This is a problem that requires focus, a sense of purpose, and continuity of effort that is seemingly alien to the human collective. Those who take up the charge, and there will be many, will have to spearhead a cultural change that will take decades. Those who are successful and thrive will learn with change. We are at a time of rapid and unprecedented climate change. We need to be using current weather disruptions to learn and prepare. We need to redefine our notions of conservation, preservation, and legacy. We need to prepare ourselves to deal with loss. We need to develop a culture of anticipating and preparing for climate change and its consequences. We need to relearn some forgotten issues. We must learn to incorporate the impacts of climate change into all that we do. Presently, we have made intuitive or codified historic climate variability into our behavior, our buildings, our agriculture, our preservation, and conservation. We have proved that we know how to do this. Now we have to do this again. We need to find important problems that can be addressed, take responsibility, and move forward with choices at individual, organizational, local, and regional scales. It is easier to take action locally than globally. It is easier to take near-term rather than long-term actions. Those choices need to consider their relation to climate change. Small choices accumulate into big outcomes. Final comments. Science and technological barriers are far more tractable than the political, societal, and cultural barriers. Basic human urges of acquisition, safety, and exploration are unlikely to be changed. Our human challenges for investing in the future, for the common good, are unlikely to change. As there are those who save for retirement and those who do not, some will participate and thrive addressing global climate change, and others will not. There will always be those with the ability and the willingness to respond to disruption, disaster, and change. They are less willing to pay to avoid disruption, disaster, and change that they feel they might not realize. Climate science provides a usable vision of the future. This is unique in all of time. It is your most certain knowledge of the future. It could be less frightening. There are techniques and behaviors to gain control over dealing with climate change, and it is our choice of whether or not we do them. Thank you for your attention.